Fine. Yesterday we have discussed about the MIPI. In that MIPI, what is C5 CSI interface, and then in that what is D5 layer and what is C5 layer, how it is connected, and then CSI architecture. In that application layer, pixel to byte conversion, protocol layer, and then low power, low level protocol, lane management file layer. All these things are we have discussed, and then how CCI will work, camera control interface will work here, and then how the data will be transmitted in, how the data will be controlled in the CSI part by using CCI. So we have discussed in that write transaction, read transaction, how it is doing that. So we have discussed. Same way, this CCI part we have discussed about different write transaction and read transaction. Same way, today also we will discuss about the CCI part. In this CCI part, camera control interface is controlling the CSI2 transmission. That means camera serial interface to transmission. It will controls the data transmission from the transmitting side to receiving side. Here, transmitter, the receiver is called as master, because I told you in that CSI transmitter, this is my transmitter. In this CSI2 is there and CCI is there. Okay, this CCI is the slave. Okay, this is the slave. Okay, so this in transmitter we have slave, and receiver side, this is the receiver. Here transmitter may be camera or sensors. Okay, receiver may be a host or processor. Okay, so this is the thing. In this CCA part is there, this CCA part will act as a master. Okay, so in the receiver side we have a master. Master can control the information, and then it will request the data, so it will asking the data control information, and then requesting the data is that needed from, is that produced by the master. Okay, master is asking data, and then slave is corresponding slave is giving the data. That means camera is responds as well as gives the data through SDA line and SCL line. Okay, so the SCL line will be controlled by the master, and then SDA line is the bidirectional line. In this, data will be transmitted. See how the message format we have discussed in the yesterday class, right? So that is the start of transmission, address bit, address 7 bit, read or write bit, acknowledgement, sub address, and then so register address or register index address. So after that, acknowledgement data, and then acknowledgement stop bit. This is the basic message format in MIPI CCI part controlling that. Okay, so this camera control interface controlling the message format. In this, we have operated in two operations like read operation and write operation. So in the read operation, we need to send multiple data like two message types we are transmitting. One is 8-bit index message and 16-bit index message. Okay, that means your sub address may be 8-bit or your sub address may be 16-bit. Okay, so what is this sub address? I told you, so we have a slave, in that some address is matching. So this address 0 1 0 1 is the address of your slave, and then in this address some location we want to work it. Okay, so that is called as sub address. Okay, sub address is that whatever the slave we have, in that some inside the address we have, so that inside address is called as the index address or sub address. This CSI, this sub address will automatically incrementing for the next transmission. Okay, so whatever the next transaction we are doing, for that kind of at that time this address will be automatically incrementing. Okay, so these are the key characteristics. We already know that SCL line and SDL line half duplex will be supports here, and then fast mode, and the maximum frequency it will be supported by 400 kilohertz, and then addressing mode is 7-bit address. That means 2 power 7 possible addresses will be having. That means 128 possible slave addresses will be had there, and then multi-slave is capable. That means here multi-master is not supporting. Actually, I²C will support multiple masters and multiple slaves, but here the master is single one. So processor is the single one, or host is the single master, but slaves will be many. Slaves will be supporting multiple slaves. Master will be single. And then bidirectional data, simply it is supporting that half duplex and open drain or open collector with pull up resistors. What is the need of pull up resistors means whenever the bus is in idle condition, it will pulling from low region to high region. Okay, for that purpose we are using this pull-up transistors or pull-up resistors. Okay, and then typical pull-up resistors will be 2.2 kilo ohms to 10 kilo ohms. We are having the typical values, and then see SCL should be high and SDA should be high. So that is in the idle condition. Or SDA should be low means that is in busy condition. Okay, so data validity, when we are having the validity means SDA should be stable, and then SCL should be high. So if we are changing the SDA line means, so then we are getting the unknown values. Okay, so don't change it except start condition and stop condition. These two conditions only SDA will be varying. SDA will be varying, and the remaining conditions SDA should be stable. We need to maintain. Okay, so in this read operation, and then we are having two sub addresses like say 8-bit sub address and 16-bit sub address. Remaining all the things are same here. Okay, so we are getting the message. We are doing the write operation. So just your write or read bit should be 1 here, and you are doing the read operation. Your write or read bit should be 0. Okay, so write operation or read operation we are doing that. So write operation we are doing that means it is 0, and read operation we are doing means it is 1. Okay, so then we are keeping some writing the data into the slave at that time start address and then slave address read or write bit. See, if it is 0 means writing the operation, if it is 1 means reading operation is going on, and then acknowledge after keeping the address we need to get the acknowledgement. So you are doing the write operation or read operation, we are getting the acknowledgement. After that index value we need to place that. In that index, either 8-bit index you are taking or 16-bit index you are taking. Suppose you are doing multiple addresses, multiple data you are doing means you are keeping in your slave means this index address will be automatically incrementing. Okay, so in that way that next address will be calculated. After that index address we reach, and then the slave will be acknowledged, and then again other index value will be taking that, and that means in the same slave other location we are accessing that. So that's why we are placing the data. Okay, same way we are keeping the reading the data from 16-bit location or 7-bit location. So in that lower bytes, we are getting this data 7-bit address. Okay, and then this is the 16-bit address. Okay, so 16-bit address we are taking. That means lower index from one index and then upper index from the other index. That means you are having the slave. This slave 0 to 7 location. This is the lower index values, and this is the upper index value. Sometimes you need to get the upper index values or lower index values. Okay, fine. Any doubt up to this? Okay. So then camera control interface, we are doing the read operation and write operation. What is the camera control interface operation here? We are having transmitter side and receiver side. So camera control interface is in transmitter side as well, also available, and receiver side also available. I told you in the transmitter side it will be act as a slave. In the receiver side it will be act as a master. Okay. Yeah, yeah. Okay, okay. See, in this CCI camera control interface, having uh, two operations like read operation, doing the two operations like read operation and write operation. See, in this CCI device, four different read operations will be there and two different write operations will be there. Reading means, I told you, slave is sending the data to master. Writing means master is sending data to the slave. Okay. So in this, I told you that in this index register address, okay, whatever the index register address, that will be incremented automatically. Okay. So this CCA part, whatever the sub address or index address is there, that address is automatically incrementing for doing multiple transactions. Okay. See here, the master is initiate the all transactions and also controls the clock signal, and it is also tells that you are doing the read operation or write operation. So that means master is placing the data or slave is placing the data. Okay, slave is sending the data. Then slave will be respond whatever the master is asking commands. Okay, for that slave will respond, and then it contains some registers, indexed registers. This registers automatically increment the registers for each read and write operation. That means you are doing one read operation, one index will be stored here. Okay, so first index will be stored, and you are doing write operation, then next index will be taking that. Okay, 0, 0, 2 will be taking place. Okay, in this way, the index value will be incrementing. Same, this message format you already know that start bit, slave address, read or write, acknowledgement, sub address or index, and then acknowledgement, data bytes, acknowledgement or negative acknowledgement, and stop bit. S means start bit, and then SR means start repetition. When you are doing the start repetition means, I told you, so you are doing one transaction, and then at that time your SDA line should be low, and then you want to do another transaction, then never access the another master from your slave. Okay, whatever the master is accessing, that should be access your SDA line, and don't give the chance to other person to access your master's SDA line. That's why just a small time it is going high, again going low. Okay, that is called a start repetition. So that means without starting the new transaction, same transaction will be going on. That means one time you are doing reading operation, and the next time you want to do writing operation. Okay, so you are doing some writing operation in one transaction, other transaction you are doing reading or read configuration you want to do, or write configuration you want to do. So that's purpose you are not releasing your SDA line. That's why you are going to continue on the same transaction. That's why start repetition is taking place here. Okay, SR means start repetition. In this way, we are transferring different indexes like index M, index K, so index M minus 1, M plus 1 in that way. So that means first index you are taking index M, and the previous index K, and the next index M. After that next index it will be incrementing index M plus 1. So every time it is automatically incrementing while transferring the multiple data. Okay, so here it is doing different read operations and two different write operations. What are those? What is the write operation it is doing here? It is doing the single write operation from random location and single write operation from current location. Okay, see, single write from random location and sequential write, not single write from random location, sequential write from random location. Okay, so for that we are having write messages. So what is the message format? Again, start bit, slave address, and then doing the read or write operation bit, and then acknowledgement, sub address, again acknowledgement, and then data you are sending, acknowledgement, and stop bit. See, this is the basic write operation. See, in this single write to random location means the write signal should be placed in any sub address. Okay, whatever the sub address we are having in the slaves region, so any location it is placing the data. Now you want to do sequential write starting from the random location means, so here you want to write sequentially. So that means master writes the first data byte to specific index. See, that means you need to write some particular location like 0 1 1 0 1 is the address location, 0x01 is the 0101 is the address location. This location you need to write the data, then continuously you are writing the data into that same location, then slave will be automatically incrementing the address location. Okay, for each data byte it is incrementing the address location. Then after that you need to increment different locations, and then you need to access the write operation to the different index locations of your slave. That is the sequential writing. Sequential means continuous writing, right? So one writing is happening and then other writing we need to do that. Okay, after that other writing should be doing that. Here one data you are placing, that means 01 index and then 02 index, 03 index. This slave will be incrementing. See, slave auto increments the index after each byte. Okay, once you are writing one byte of data, in the next byte of data you want to write it, then this subaddress will be incrementing, and again acknowledgement you will be getting. After that again you want to write another data, again this subaddress will be incrementing. Okay, so index address should be slave is automatically incrementing for successful read or write operation. If you are receiving NACK of NACK bit means, that means master indicates that last byte of read sequence, that means your transaction is completed, or you're receiving some error in your transaction, or slave is not acknowledged, that is the NACK indication. So two types of NACKs are there. One NACK is related to master. So then master is this master indicates that last byte of data in your read sequence means you are getting the NACK operation. Okay, and then another thing is your slave is not responding. Whatever the slave you have, this slave is not responding. That means whatever your address sending, that address is not matching to particular slave. Then no slave is responding to your master condition. At that time also you will receive negative acknowledgement. Understood? So that is the single write to random location. Single write only, one write only you are doing that. And then sequential writing means multiple writing operations you are doing on the same slave. Then the slave will be automatically incrementing your next address. Okay, based on the next address, the data will be stored. And then read operation, what are the read operations are there? Single read from random location, sequential read from random location, single read from current location, sequential read from current location. See, single read means whatever the you need to send the dummy address. Okay, master performs that. Okay, some dummy write operation. Whatever the desired index you have, in that desired index, this is my desired index address. In that desired index address, master is placing some write operation. Okay, so in this write operation, it is doing that some additional information, or some information is placing that. Then your slave will not release that, your master is not relieving your. Yeah. Ah, okay, okay. Similarly, we have four different read operations. Okay, so what are the different read operations we have? See, single read from random location, sequential read from random location, and then single read from current location, sequential read from current location. Okay, same single read, sequential read, single sequential read, sequential read from random location, sequential read from current location only. Like same way, single read from random location, single read from current location. Okay, so four different operations we have. See, single read from random location, how we are doing that random location means, so randomly the master is placing some data in that sub address register, whatever the sub address register address we have. Okay, sub address register address we have. So that register address, that write master will placing the dummy write operation. After that, issues that start repetition condition. Then start repetition condition issued means your master doesn't want to relieve your SDA line to idle, because the next master will be takes place to operating condition. That is the reason I don't want to relieve my SDA line from low to high. Okay, so that is the start repetition condition. That means without going to the again start condition, again I want to do another transaction. That is called as start repetition. Okay, so start repetition means here it is doing the some address conditions, again slave is again doing the read operation, and then it will send the acknowledgement bit. So slave will send the acknowledgement, then slave output data, whatever the data we have, this SDA line will send to that master. Okay, if master receives that NACK means your receiving address is wrong, or you are sending then you are receiving that NACK means then your data will be completed. That is the single read from random location. In this, master doing some dummy write operation. Dummy write operation it is doing that. After that, issuing the start repetition condition. Then slave will send the data from that save write location. Then master is receiving the data. That is the single read from random location. Same operation. See, start address, start condition, slave address, master wants to do the write operation here, and then acknowledgement. After that, slave sub address you need to send some acknowledgement. After that, while placing the data, you need to do the repetition, start repetition. That means without relieving the write operation, I am doing the read operation here. Okay, the slave address will be continuing the read operation. That means slave is sending the data from slave to master. After that, sending the data, you will receive the negative acknowledgement. That is the last data transmission. Then master will stop the transaction. This is what doing in single. See, dummy write operation why we are doing means I don't know which location I'm getting the data, right? So this is my slave. Okay, in this slave, okay, where I need to get the data. So then I don't know which location. Then the slave, the master will keeping some write operation. Based on that, which location I'm having the data, we will know that. Okay, so then the master will receiving the data from the slave. Okay, that is the random location means, see which location you are there means I don't know. Then I need to test which place is, see, some different vessels are there, so all are filled, some of the location is empty location. I don't know which vessel is empty or which vessel is full. So then I need to knock the vessel, so it will use the different sound, right? So based on that I need to know that, okay, so this one is empty, this one is full. Based on that it will send the dummy write operation. Okay, same way, single read from current location. Then there is no doing the write dummy write operation here. So master addresses the slave with read operation. Okay, whatever the read operation you are doing that. So then master will address that. Then slave will be responding. That means master is giving the address location. Based on that address location, the slave will be responding. Then slave will be giving the data. So then read operation is normally doing that. If you are going for the random location, that is the problem, which location I need to get the data. Same way, sequential read starting from the random location. So sequentially you are doing the read operation. Similarly, same way, master writes that some desired index location, that means dummy write is doing that. After that, issuing the start repetition. Once the master is receiving the data from the slave side, okay, so multiple data bytes I need to receive from the slave. At that time, if master is sending the acknowledgement, okay, so I have received the data, then continue reading. So that means after receiving the last byte of data, then the master sends that negative acknowledgement. Then it will stop the transactions. Okay, so same operation, the whatever the single read from random location we are doing, same thing will be sequential reading from starting from a random location is also doing the same thing. Same dummy write operation we are doing that, and then slave will responding that. Slave will master is issuing that start repetition condition. Then slave will sending the data to the master, but multiple data is asking. Then different data, see previous one single data only sending. Here data 1, data 2, data 3, and so on. So n number of data are sending. So because these indexes will be incrementing automatically. Then the slave will be incrementing the automatically, same this different locations the data will be reading. Once the master is setting the negative acknowledgement bit means, so I'm stopping the transactions. Okay. Same way, sequential reading starting from the current. Yeah. Hmm. Yes, pull up resistance and also pull up resistors also we are using for pulling your SDA line to low to high. So that is the purpose we are using pull up resistors. Pull up resistors. When it is comes into your picture, me no, here we are not using any pull down resistors. Okay. Hmm. Uh, why pull-up resistors means this resistors is depends upon the delay. Okay, TR equal to depends upon the delay. That means resistors and capacitor. So depends upon the resistance value and capacitance value. We are calculating this delay. So based on that, we are operating some frequency, right? So frequency is the 400 kilohertz or 3.2 megahertz. Based on that frequency, we are calculating the delay. So then, yeah, no one will taking place to once the SDA line is idle condition or busy condition only. They are checking that. Master is only checking that your SDA line is should be idle condition or busy condition. That thing only I am checking that. But I'm not the responsible person to keep my SDA line from low to high. So there is an another person is there, that is the pull up resistors. RP values are there. So these RP value will be keeping that SDA line from low to high. Then only the next master will know. So my your SDA line should be in idle condition. Then it will be accessed. Then next master is the master is ready to pull that high location to low. Okay, so whatever the high value is there, that high value is ready. The master is pulling from high to low. That operation it is doing that, but low to high it is not doing by the master. It is doing by the pull up resistors. Okay. So once your data is transmitted fully means, then pull-up registers is come to into your picture. Then it is doing that low to high of your SDL line. Same thing we are doing the sequential read starting from the current location. Same thing, single read from current location. How we are doing that? Same way we are doing the sequential read starting from the current location. Similarly, we are doing the sequential read from random location. our current location. See how we are doing means multiple data we are reading from the um, same location, right? So for that, for the random location we are doing the dummy write operation, but say current location we don't, without doing any dummy write step. Okay, so master reads the multiple data sequentially from the current index, whatever the current index you are giving. This is my current index 1001 is my current index. From that index we are reading the data. Okay, so that is, but it is reading sequentially. So because the slave is having the feature to increment the address, so based on the incrementing address, it is getting the data from the different address locations. Okay, so these are the write read operations in CSI, sorry CCI, camera control interface. Four read operations, two write operations. Okay, how multi-byte registers will be addressing in the CCI part. Same thing. Okay, whatever the read operations we are doing, write operations we are doing in the CCI part. Hmm. Tell me. Hmm. 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 Okay, so current location is, this is incrementing whatever the address you are sending. That address, based on that address only, it is incrementing that. So if you want to get the previous address location, so then you need to send the another address location like 1000900 F you can send. Okay, in that way you need to see this index will be incrementing, and then also previous index values also we are getting that. Okay, so incrementing value is there, and then it is also decrementing. That means same address location I want to get the data. So then it will be sending. It will be getting the data by pushing, by popping back. So doing some pop operation like a queue operation. So we are having different address locations. We are doing some pop operations. So then it is doing the pop operation by friend, or it is doing the pop operation by back. Push, pop front, pop back also there, as well as push front and push back also there. Okay, fine. Okay. So then we need to discuss about multiple multi-byte registers. How the multi-bytes data will be transmitting by the CCI part. In this CCI, we are operating on fast mode. So this fast mode, that means 400 kilohertz frequency. It is supported by the I²C. So here also we are having CCI receiver and CCI transmitter. So CCI transmitter may be the master, and then CCI transmitter is the whatever the master we are having, CCI transmitter, right? So that is CSI receiver. In this CSI receiver, okay, CSI receiver is there. That receiver will be acting as a master, and then CSI transmitter is there. That master transmitter will be acting as a slave. Okay, so same will be supporting here by the multiple multi-byte registers. How the multi-byte registers we are having means 7-bit address location we are having, right? In this last bit will be toggle. That toggle unknown value means, see, this unknown value may be either 0 or 1. So that is the why, that is the reason why we are doing the multiple multi-byte registers. So one value, so this unknown value will be taking as 0, or one time it will be taking as a 1. So then it is possible to transfer the data like 1 bit or 2 bit. In that way it will be transmitting. See here 0 1 1, 0 1 1, and 0 1 1. 6 bits are there. So this unknown value will be taking as a 0, that means 0 double 1 0 double 1 0. Similarly 0 double 1 0 triple 1. In this way we will calculate the data here. Okay, so how it will be taking place here, 3 bits will be considered as a 6 and this will be considered as a data like, see, this is the MSB bit, this is the LSB bit. So MSB bit to LSB bit we are transferring the data. So then my address is that um, this is the 6. Okay, so 0 double 1 0 double 1 0, these 4 bits will be treated as 6 and these 3 bits will be treated as a 3. So then 36 will be the address location and similarly 1 is added means 7, that is 7 and 3, 37 is the next address. Okay, so that means this is the raw buyer output camera and all other cameras like different address, 7-bit address like 0 double 1 double 1 0 x is there. So same way, so 0 double 1 double 1 0. Okay, so and then the next bit will be 0 or 0 double 1 double 1 0 1. So based on this, we will calculate the next addresses. Okay, this multi-byte registers will support either 8-bit. 8-bit is the generic set of registers, and 16-bit. That means you are parameterizing. That means your frame length will be increased, and then length of the so that means parameter should be related to your length. Then frame length should be increased. After that 32-bit, that means precision values, some values like negative values or point values we will get, right, floating values we will get. For that 32-bit location we are considering that. And then 64-bit, so 64-bit for future sensors purpose. Okay, any sensors like EP, ROM, different sensors, camera sensors are there. So those camera sensors purpose it is reserved for future sensors. Okay, and then how the data will be transmitting, like suppose some address is sending, that address is that 8000, that is the address location. In this way the address will be incrementing at 801 802 803, whatever the start address is there, that is the MSB bit location, because this is the MSB position and this is the incrementing address is there, that is the LSB position. That means you are transferring 4 bytes of data. Okay, these 4 bytes of data we are transferring from one register. Similarly, another register we are transferring the other data. That means you are doing the read operation sequentially. Sequential read from current location can be used for both read registers. That means multiple operations you are doing means, okay, multiple read operations you are doing means that is the sequential read. That sequential read you are doing the current location or random location also you are doing that. Okay, how the transformation bytes will be ordered for multi-byte registers. Okay, write operation we are doing that. That means 16-bit registers I am using here. For that, one data byte I'm using 8 bits. Okay, that is one data byte will be writing in your slave address location, and other data byte will be writing into that other location. Okay, so then one data we are transferring from master to slave, and then other data is transferring from slave to master. So same thing we are doing the reading operation, but once we are doing the write operation and once we are doing the read operation without releasing the my whatever the address location is there, right, whatever the SDA line is there, right, that location I don't want to relieve that. Again I'm doing the start repetition condition, then my address will be sending. Or you can do another operation also. First you need to do the write operation. How you are doing the write operation, start bit will be sending and slave address you doing the write operation, and sub address you are placing. After that receiving the acknowledgement, and then data byte will be stored. After that acknowledgement will be getting, and then next data bytes will be stored. See, 3 data bytes we are transferring, not only 3. See, 0 to 7 and 16 to 23 and then 24 to 31. Then 4 bytes of data you are transferring. All the 4 bytes of data you are placing one address location, then it will be incrementing. After that, same way I am doing the read operation. So here, write operation we are using 0 and the read operation this bit will be 1. Same way I am doing the different read operation. Then 0 to 7, 8 to 15, 16 to 23 and 24 to 31. Here another data is missing here. See, 0 to 7, in between that we need to send um, 8 to 15 data. So this data is missing in the write operation. Okay, but it is sending the same 32-bit data. After that, we are receiving the um, multiple data. Okay, that is the multi-byte register addressing. See how the registers we are working here means registers resides the byte-oriented address space. That means 8 bits, 8 bits. In that way, the data will be transferred. So first byte will be the MSB bit. Whatever the MSB bit we are having, that byte is sending by the MSB bit. And then here multi-byte is not continuous. So continuous locations will not be there. So the address is continuous. Address of continuous multi-byte registers are not continuous. That means not sending the same address location like 100 is the address location. So this address location you are writing one write operation, and then the next write operation not in the 1001 location. It may be written into the other location also. It will be written 1010 location also. It will be writing that. So that means interleaving maybe happens. Then the mixing of data will be taking place here, or another location like different address locations will be taking place. That means mixing of data will be happening. Okay, so that is the purpose. It is not continuous. Different locations of address we are reading the data. Okay, fine. Fine.